Welcome to lesson 5. I'm going to apologize now. You're not going to like it. So here we're going to take equations that have multiple different variables and solve them for a specific variable. So my first example, I have v minus e plus f equals 2, and we've been told to solve for v, which means we want to leave that alone and get everything else away. So this negative e has to come across, and a negative e would move by addition. This positive f has to come across, and we would subtract. Okay. V equals. There is nothing to combine on the right side here. It is literally 2 plus e minus f. Okay? This is going to be strange. V minus e plus f equals 2. Same equation, but this time we're being asked to solve for e. So we have to get e alone. So v is positive, I will have to subtract v. F is positive, I will have to subtract f from each side. And there's nothing to combine those with on the left here. So the negative sign is still attached to the e. I'm going to have 2 minus v minus f. I can't have negative e equals. So I will have to divide everything by negative 1, which has the effect of switching all the signs. So e is equal to negative 2 plus v plus f. A equals 1/2 BH, the old area formula for the triangle. And we are tasked to solve for h. Oops, come back here. I need that. We are asked to solve for h. Now you see a fraction? You should be drilled by now. First thing to do when you see a fraction, let's get rid of it. 2 times a is 2a. 2 divided by 2 is 1 times 1 is 1. So that just gets rid of the 1/2 on the right side. Now I still need, the task here is h by itself, which it's not yet. It's got a b multiplied to it. So to undo multiplication by b, we will divide by b and get 2a divided by b is equal to h. Okay. Let me give myself a little more room to write here. For the next guy, we have a squared plus b squared equals c squared, the old Pythagorean theorem. And we're being asked to solve for a. Okay. This is a two-step equation. An exponent is kind of like multiplication on steroids, I guess. We will definitely deal with it last. So the first thing we got to do is subtract b squared from both sides. It's positive. To move it, I have to subtract. So a squared is equal to c squared minus b squared. And now I have to undo the square. The opposite of squared is square root. So I am going to take the square root of both sides. On the left side, that'll leave the a alone, finally. On the right side, I just have to write out the square root of c squared minus b squared. I can't do anything else with that. On the right side, they don't cancel out because of the subtraction. And my last example, we have s equals 2 pi r squared plus 2 pi r h. And we are asked to solve for h. This is the formula for surface area of a cylinder. Either way, there's a bunch of stuff multiplied to h and some stuff added to the h term. So it's a two-step equation. I'm going to start by subtracting all of this term from both sides. I'm just going to do that because I don't really have the room to write that neatly underneath the s. So I'm going to have s minus 2 pi r squared plus 2 pi rh. That's not a plus sign, that's totally an equal sign now. Let me make that an equal sign like it should be. I want h by itself. It's being multiplied to a bunch of things. So let's divide by the bunch of things. There is subtraction in the numerator you may not cancel. So this is s minus 2 pi r squared divided by 2 pi r. I cannot write an r in this little space to save my life. R, good enough, is equal to h.